Electronegativity. What is electronegativity? Electronegativity is the tendency of an atom to attract shared pair of electron towards itself. If we say electronegativity of a certain atom is more, that means its attraction for the electron is more. It loves the electron more. And if we say electronegativity of certain element is less, that means it doesn't like electron. It doesn't attract electron. All right. So that is a very simple definition. You can say love for electron is electronegativity. So the more the attraction for electron, the more is electronegativity of an atom. So what is the trend in periodic table? If you watch in a group, the electronegativity of atom keeps on decreasing down the group, and across the period, electronegativity keeps on increasing. I'll tell you a trick to remember the properties in physical and chemical properties in this chapter. Let's say if you remember atomic radius, it increases down the group and decreases across period, and other properties just reverse it. Atomic radius increases, electronegativity decreases, electron gain enthalpy decreases, ionization enthalpy decreases down the group, and across the period atomic radius decreases and other properties increase. Electronegativity increase, electron gain enthalpy increase, ionization enthalpy increase across period. Alright. So I think I gave you a very nice trick. Just remember this. Now, electronegativity, which element has the maximum attraction towards electron is fluorine. Fluorine is the most electronegative element in the periodic table. Out of 118 elements, fluorine is the most electronegative element. That means nobody loves electron more than fluorine. If fluorine is present, nobody can get electron from fluorine, right? So there is a Pauling scale. On Pauling scale, the maximum value of 4 units have been given to fluorine, and the second highest electronegativity belongs to oxygen. It has 3.5 units of electronegativity. Then nitrogen and chlorine have almost similar electronegativity, and they have been assigned a value of 3 units on electronegativity scale by Pauling. Alright, few formulas which were made in use by Pauling for the calculation of electronegativity we have mentioned out here. Electronegativity was compared Xa and minus Xb. Xa is electronegativity of A, Xb is electronegativity of B. That was compared with the bond energy values. We took the use of bond energies, so you can calculate the electronegative values over here. There was another scientist whose name was Mulliken. Mulliken used another scale for calculation, and his values were 2.8 times higher than Pauling's electronegativity values. I'll tell you the trick to remember top 4 elements in the periodic table on the basis of electronegativity. So you just remember phone call. What you will remember? Phone call. Fluorine, oxygen, nitrogen, chlorine. So phone call, that is the fluorine the highest, and nitrogen and chlorine almost similar. Alright. So what is the purpose of electronegativity? I'll share a small glimpse for you. If let's say we have a bond between H and Cl, right? So what happens is this is a covalent bond. It should have 2 electrons, one given by hydrogen, another given by chlorine. The 2 electrons should be at the center, but that doesn't happen. Why? Chlorine has more electronegativity, so these 2 electrons get shifted towards electron. Electron pulls shared pair of electron towards itself because chlorine is more electronegative than hydrogen, because of which it almost gains one extra electron. So the charge on chlorine is partial minus, and hydrogen has almost lost its electron, so the charge is partial plus. So this is what happens due to difference of electronegativity. If we take atoms of same atoms, a bond between same atoms, then they have the maximum, there is no difference in electronegativity. So this is called a polar bond. This is called a polar bond, and the bond between same atoms is called a non-polar bond. So higher the difference of electronegativity between atoms, higher will be the polarity of bond. that is used in chemistry. You will be using it in most of the cases in organic chemistry, in inorganic chemistry. This is highly used. So electronegativity difference causes polarity, because of which you can understand when bond breaks which atom will get a negative charge and which atom will get a positive charge. All right. So this is it on electronegativity.